Today we're going to use matrices to do reflections. Now we are going to limit things quite a bit because we need to keep it relatively simple. So we're going to limit ourselves to reflections in the x-axis and the y-axis here. We aren't going to worry about reflecting in the line y equals x or y equals negative x or in the line x equals 3 or anything like that. We're going to really try to keep it focused on two things. When we do a reflection for our matrices, we're going to use one of these two special matrices, and we're going to multiply the reflection matrix times the coordinate matrix, and the result of that multiplication is going to be the new coordinates. Now, this is something that's pretty easy to verify graphically if you want to, because reflection in the x and y axis are pretty easy to do. But I want you to work on matrix multiplication here. That's one of our goals. So we're going to want to see when you're doing work on this, the actual matrix multiplication taking place. So in order to do this, here's the procedure we have to follow. When we're doing this, first find the coordinate matrix for the polygon. Second, multiply the correct reflection matrix first by the polygon matrix second. So when we're doing the multiplying, the reflection matrix has to be the first one and the coordinate matrix the second one. If you make a mistake on that, the multiplication isn't going to work. So you'll know if you've made a mistake on that pretty quickly. Let's take a look at an example. I have a triangle with vertices at the given coordinates, A, B, and C. So I'm going to go ahead and create a coordinate matrix for that. That's 2, -1, 6, 5, and -3, 3. And I want to reflect it in the x-axis. So I'm going to put my x-axis reflection matrix, which is 1, 0, 0, -1, first. And now I'm going to multiply these matrices. Now, it's going to work because we multiply row by column. If I put this 1, 0, 0, -1, if that had come after, if we put it in the wrong order, I can't multiply because I can't take row 1 times column 1. There are 3 entries in row 1, only 2 entries in column 1. The multiplication will not work. So we have to go ahead and do we always have to do that transformation matrix first for the multiplication. And now we just go ahead and review our multiplication. Now with all the zeros, the multiplication is actually going to be very, very simple. I mean, all we're dealing with is ones and zeros. So the actual computation isn't that bad. We just have to remember a process. It's row 1 times column 1 is going to give us the row 1, column 1 entry. So 1 times 2 is 2. 0 times -1 is 0, so I get a 2. Then I take row 1 times column 2. That's going to give me the second row. 1 times 6 is 6. 0 times 5 is 0. 1 times 6 is just a 6. Now row 1 times column 3. 1 times -3 is -3 plus 0 is -3. Notice my top row didn't change. Now I go to row 2. Row 2 times column 1. That's going to go here. 0 times 2 is 0. -1 times -1 is +1. 0 times 6 is 0. -1 times 5 is -5. 0 times -3 is 0. -1 times -1 times +3 is -3. Aha, so my A primed is at 2, 1. My B primed is at 6, -5. And my C primed is at -3, -3. So with matrices, we've been able to do this, again, without a diagram, without having any rules memorized other than what is the correct reflection matrix. So not too bad. I'll reflect the polygon in the x-axis, use matrices. So again, my points, the first thing you want to do is identify where my points are. My points are at negative 1, 1. This point is 1, 2, 3, 4, 5, 1. And this point is negative 1, 7. I want to reflect in the x-axis. So I go back, I look, what is my, for the x-axis, 1, 0, 0, negative 1 is my reflection matrix. My coordinate matrix, and this could be whatever we call it. Let's call this A, B, C in that order, just going around clockwise. So negative 1, 1, negative 1, 7, 5, 1, and we do our multiplication. And I think you've already noticed probably the pattern here. 1 times negative 1 is negative 1, 0 cancels that out essentially, so I get negative 1. 1 times negative 1 is negative 1 plus 0 is negative 1. Row 1 doesn't change, does it? And what happens in row 2? Let's refresh it. 0, that gives me a 0. Negative 1 times 1, it changed the sign to a negative 1. 0, negative 7, aha, negative, second row just changes sign. So there's my A primed, B primed, C primed. All done. So the pattern comes out really fast. Not only is the multiplication really not that bad, but the pattern becomes very obvious to us very quickly. I think you'll like that. Reflecting the y-axis using matrices. Okay? So we're going to use the other reflection axis or matrix now, negative 1, 0, 0, 1. Whoops. So negative 1, 0, 0, 1 is my matrix. I need my coordinate matrix. I'll call this point A. That's at negative 3, 6. I'll call this point B, which is at 0, 5. And I'll call this point C, which is at negative 2, 1. And now we'll do our multiplication. So again, row 1 times column 1. Now this is a little different because I have a negative 1 now. Negative 1 times negative 3 is positive 3 plus 0 is positive 3. Negative 1 times 0 is 0 plus 0 times 0 is still 0. Negative 1 times negative 2 is positive 2 plus 0 is positive 2. So we change the signs in the top row. Now, row 2, starting with column 1. 0 times negative 3 is 0, plus 6 is 6. 0 plus 5 is 5. And 0 plus 1 is 1. So there's my new A primed, B primed, and C primed. And if I wanted to plot those points now, I could. It's at 3, 6. There's A primed. B primed is actually the same point. C primed is right there. There's my reflected triangle. So while looking really complicated, reflecting using matrices is actually pretty simple and also follows patterns pretty quickly. For your daily check, I want you to reflect this particular triangle in the y-axis. And again, well, I'll just give you the points real quick. We'll call that 1, 1. We'll call that point A. This is point B. It's at negative 1, 8. And this is point C. And that is at 1, 2, 3, 4, 7. So that'll help you set up your coordinate matrix. You're going to have to pick the correct reflection matrix and do the multiplication. And I'm going to want to see that multiplication worked out, not just a picture. I want to see the multiplication itself. Remember, you're reflecting in the y-axis. Give it a shot, and we'll see you in class.